There were a number of questions asked during my talk that I couldn't answer immediately afterwards, so I'm going to provide the answers right now. The first question was, is this presentation compatible with Genesis chapter 1? And that's a good question. It's largely a spiritual, faith-based question, and it doesn't really come into the realm of science, but I will point you to the work of Hugh Ross, who has written a number of articles and, in fact, books on this topic of how the scientific account of Genesis matches or not with the biblical account. So his name is Hugh Ross. He's an astronomer and has written several books on this topic. The next question is, will the imaging capabilities of the JWST also aid in checking the current value of Hubble's constant? The answer to that is yes. One of the tasks of JWST is to work on improving our knowledge of the Hubble constant. The next question is, do you think there is an Earth-like planet in any of these dwarf galaxies? Maybe not humans, but living organisms. And I approach these questions about Earth-like planets really with a statistical approach. Considering how many stars there are in the galaxy, even in dwarf galaxies, and how many stars are likely to have planets around them, and then how many planets are likely to have life, I think statistically speaking, there's a good chance that there are Earth-like planets around stars in these dwarf galaxies. So that's really all I have to say about that question. The next question is there a theory about why the leftover dwarf galaxies didn't incorporate into the larger organized galaxies like the Milky Way? Well, the answer to that is they're still incorporating into the larger galaxies. So the process of galaxy formation really isn't done yet. They're still going on. There are galaxies right now, dwarf galaxies right now, that are orbiting the Milky Way and that are being shredded and destroyed and incorporated into the Milky Way. The same with Andromeda. And so that process isn't done yet. It is still going on. The next question is, where can students get more information on careers in cosmology, as well as getting involved in research opportunities? So I would say there, the best place to look is the website of the American Astronomical Society, AAS. Their website is AAS.org. And if you go there, you can read all about careers in astronomy and how you would go about training and getting degrees in astronomy if you want to be an astronomer and do research in those areas. Plus, let me just say right now that you're welcome to email me and we'll have a conversation about what you'd like to study and what direction you'd like to go. And, you know, we can discuss the best direction for your future academic pursuits. And my email is simply my first name, ATA, @ fau.edu. That's ATA@fau.edu. Feel free to email me and we can start that discussion. The next question is, one of your slides referred to a period or event known as the expansion of dark energy. Can you explain what this refers to? Yes, you're right. There was a slide in my presentation that talked about the expansion of the universe through dark energy. And that refers to the current situation where we have this mysterious force in the universe that's causing it to accelerate, to move, to expand faster than we would have otherwise expected. And we don't know what this force is, what this energy is, but we call it dark energy because we don't know what it is. And so, you know, we live at a time when, yes, the universe is accelerating in its expansion, and that acceleration is caused by dark energy. You're right, that was on one of my slides. The next question is, are the colors in the images you showed us completely natural or augmented to some extent? The vast majority of the images I showed, the colors are completely natural. They are true color images. The colors themselves might be enhanced slightly to bring out detail or contrast in the images, but for the most part, those colors are true colors of those images. The next question is, what is at the center of our galaxy? What causes it to spiral around the center point? Well, at the very center of the galaxy, there's a black hole. And the black hole, along with its gravity, causes the stars in the immediate vicinity of the center to orbit the center of the galaxy. What causes it to spiral around the center? Well, we're not completely sure, actually. The theory of spiral structure, the theory of spiral formation is still being worked on. But if you'd like a buzzword to do a search on, the current best theory is what's called the density wave theory. And I would welcome you to do a search on that on the web and read more about it. It's called the density wave theory. The next question is, considering the HST's many successes, why is NASA decommissioning it before James Webb is operational? Well, my understanding is that they're not, that HST will continue to work and operate as long as it can mechanically continue, and that NASA will continue to operate it as long as they can, and there'll hopefully be some overlap between when HST is operating and JWST is operating as well. So as far as I know, there are no plans to decommission the Hubble Space Telescope. The next question is, if looking farther away means looking further back in time, how do we know that we're not looking at a few galaxies, but at many different times simultaneously, rather than many different galaxies? Well, the short answer to that question is that when we take a spectrum of each galaxy, that is to say, when we take the light from the galaxy and we spread it out into its component colors, we can actually see the signature of that galaxy in terms of how fast it's moving and what it's made of. And if it was the case, we were looking at the same galaxy at many different times, then the spectrum would look very similar, if not identical, between those different galaxies. And we don't see that. The spectra look different. So that indicates that it's different galaxies at different times, or possibly different galaxies at the same time. Can you explain the Perseid meteor effect? Right, so August 12th was the Perseid meteor shower, and what happens there is that the Earth, as it goes around the sun, passes through the debris left behind by comets. There are a number of comets through which our orbit passes throughout the year, and they happen roughly about the same time every year. And August 12th is a time when the Earth's orbit passes through a particular comet's orbit, and the debris left by that comet then passes through our atmosphere, and we see that debris as meteors in the sky. And that's what's happening with the meteor shower. The Earth is passing through the debris left behind by a comet that has moved through the Earth's orbit at that location. There's another question about where you can obtain information about the distances and redshifts of the Hubble Deep Field galaxies. Is there a database that we can easily access? And again, there I would say, please email me, and I will send you a reference that will provide information for your work on the database from the Hubble Deep Field. It's easier for me just to send you the reference by email rather than telling you here in this video. The next question is, let me see here. It's about, again, different references, recommended references for projects in astronomy and physics for students. And once again, I would just ask you to email me at hea@fau.edu, and I'll be sure to have a conversation with you about what are relevant references that you can refer to for your work. The next question has to do with the Hubble constant and the fact that it has recently been renamed to include Lemaitre's name. So now really officially it's called the Hubble-Lemaitre constant. And this is true, it is. Hubble was the observer who contributed to the determination of the Hubble constant, and Lemaitre was the theorist who came up with the details of the expanding universe. And his name has recently been added to the constant as well. So technically, yes, it is the Hubble-Lemaitre constant. However, I'd say most astronomers are not quite used to referring to it by that name yet. The next question is, can a galaxy form inside another galaxy? can a galaxy form another galaxy within it? Technically, yes. We actually have several dozen galaxies within us. That is to say, there are dwarf galaxies orbiting the Milky Way right now that are technically speaking inside ours. So if you look at it that way, that the dwarf galaxies that are left over from the formation of the Milky Way are actually inside the Milky Way, then yes, galaxies can form inside other galaxies. And then the last question is, are there any phenomena where our galaxy collided with another dwarf galaxy in the past? And is it possible in the future? And the answer is yes. We have in the past collided with dwarf galaxies and are currently doing so. There are dwarf galaxies that are orbiting the Milky Way right now that are gravitationally interacting with our own. And the impact of the gravity is actually disrupting those dwarf galaxies, as we speak. And again, if you want more information, please feel free to email me at ata@fau.edu. I would be happy to provide you with more detailed information and references and such that you can go to for further reading. Thank you very much.